All right, guys, thank you for joining. Sorry for the interruption. Please bear with us.
All right. Thank you all for joining this. We have also started recording, and I think this should work for us right now. Please, our speaker, can you hear me? Our speaker, are you there?
Yeah. I can hear you. Uh,
Okay, cool. Yeah, so if you are still on the Zoom, please kindly exit. I've also shared the link on the private channel for anyone that wants to join this particular call. So I think you have the floor right now, our speaker. Thank you very much.
all right. Thank you very much. Okay, so let me just proceed to share my screen. Um,
Yeah, does that work? Does sharing of screen works right
yeah,
now?
it's working here. Yeah, it's working here.
Okay, cool, cool, cool.
So it's coming up. Hello, can anyone see my screen? I don't know.
Yes,
Okay, it's
we can
coming up
see
Yes,
it
now.
we
I
now.
can.
can see your screen.
Yes, but
All
we are
right.
seeing two browser tab. I don't know if you want to
Oh, okay.
um
Sorry. Yeah.
share it specific.
We have to. Let me just go here. All right. So, yeah, good evening, everyone, once again. Yeah, my name is Catherine Ojuku, and I'll be taking you from Web 2 to Web 3, like helping you write your first smart contract. And yeah, let's dive in. Okay, so before we start, I want to um, like give you hints on how you're going to benefit from this uh, session or from this uh, what is it called again? Okay, let's stick with session. Um, so first thing first, it to pay you or it to do you good to have a writing material. That's number one, and also it to do you good to ask questions because the journey we are about to start, you hear a lot of unfamiliar terms, new words, and all of that. So ask questions. Mr. Idris said questions will be asked at the end of maybe the whole session. But I don't know. I feel maybe before the end of the session, someone might actually lose like the question they want to ask and all of that. So I was thinking if maybe we should do question after each topic, like uh, after each of these bullet points, so we can just take questions. I don't know if that works. So before we move to the next, we take questions, move to the next, take questions, just short questions, and we move to the next. I don't know if that works.
Yeah, I think that should work fine. So in as much it doesn't, just delay the whole thing, as I know that we have like quite a few more things to cover. So I think that should work. I think per slide should work.
All right, all right, all right. So okay, then that's one. The second one. So the last one is so this whole blockchain ecosystem, everybody is learning. Everybody is learning. It's just that people are different level or stages of learning. You understand? So we are all learning, and the best way to learn is to research. Like research should be your best guide. So with that said, now let's dive in. So these are table of content. So let's go to this first guy. So we'll be going to blockchain introduction and conceptualization. And our content, we have contextualizing blockchain, distributed ledgers, consensus mechanisms, public and private blockchains, distributed ledger platforms. Then on these other blockchain primitives, we have cryptographic hash functions, we have public key cryptography, Merkle trees, data structure, smart contract nodes, multi-chain example. Okay, so now before we move into this, okay, let's just start. So blockchain technology is a structure that stores transactional data, also known as the block of, of the public in several databases known as the chain in a network connected through peer-to-peer.
Yeah, sorry,
So
sorry to cut you. Sorry, can you please zoom in?
yeah.
I think people are finding it difficult
Oh,
to see your screen.
oh, really? But oh, okay. I thought this guy is big enough. All right, let me just zoom in from here.
Yeah, just help zoom in, please. Thank you.
Okay. How big is this now? How is this? Is this okay?
Yes, it's okay. But can you make this full screen on the slide? Is it possible?
Oh,
Can you
okay,
just share
okay. Let me
your
make it
screen,
full.
like present directly?
Okay. All right, let me
I
do
know it
that.
will be way big on your screen, right? But just for the purpose, some people are on their phone and they need to also see what is going on.
All right. All right. Why is this? Okay, I think it's coming. All right. Okay.
All right. I believe this should be fine. Okay, yeah. So that's thumbs up from the
Okay.
person. Yeah, perfect. Thanks.
All right.
I'm
Okay. Yeah.
sorry, too. I feel
So
like most people are using their phone. Sorry. Most people are using their phone. So if you are using your phone, you to kind of zoom in into the screen so that you see it better. So I know
Yes,
that it's
for
kind
yeah,
of
audio.
noticeable to
you
people
can
using their
pinch
phone.
in or pinch out. Yeah.
Yeah, exactly.
All right. So this whole stuff you hear about blockchain. So the best way to explain blockchain to you is blockchain is like a public database, right? It's a public database where um, transaction records are being stored. But this time, it's not like your normal MongoDB database or your MySQL database. Now, these transactions are stored in kind of blocks. Now, and these blocks are interconnected with one another. That's how these transactions are are being stored on the blockchain. And these transactions or this database is accessible to everybody, to anyone who connects to the blockchain using their laptop. And the way you connect to the blockchain is by downloading a client, most times an Ethereum client, and your laptop is the node. You download the Ethereum client, and with that, you can connect to the blockchain. So anybody can connect to the blockchain. So it's a database that stores transaction records, and that's just basically what blockchain is. So these records are interconnected using these blocks are interconnected by using chains, and that's why it's just called blockchain and all of that. So if you have maybe the genesis block, which is the block 0, now the block 1 will have the hash of the genesis block in it as the previous hash, and the block 2 will have the previous hash of the block 1, and the block 3 will have the previous hash of the block 2. So this is how they are connected to each other, and that's what makes it that chain of blocks. All right. So, and we now have every transaction in this ledger blockchain is authorized by the digital signature of the owner, which authenticates the transaction and safeguards it from tampering. Now, what makes the blockchain so wonderful and sweet is that, well, whenever you're trying to initiate a transaction, you need to sign that transaction, and that signing that transaction authenticates that, okay, it gives the blockchain a way to know that, okay, this person is the actual owner or the actual person that is initiating this transaction. So for instance, if you want to send crypto from one person to the other, you have to sign that transaction that you're authorizing this transaction. So this digital signature is like, it's being signed using your private key in your account and all of that. So that's one of the things that makes the blockchain really wonderful. So it's the best way to understand blockchain, just see it as a database that connects data in blocks, and each of these blocks contains transactions, records, and all of that. All right. So the next thing we are going to look at is distributed ledger. So a distributed ledger is a database that is consensually shared and synchronized across multiple sites, institutions, or geographies, accessible by multiple people. It allows transactions to have public witnesses. So now, the best way to explain distributed ledger now, one of a typical example of distributed ledger is our banking system. Now, our banking system, they don't make use of centralized databases. For instance, if you have UBA banks located all over the country, now if the UBA bank in Abuja, let's say the UBA bank in the central area of Abuja gets demolished or gets burnt, it will not affect the record. It will not affect the balance in your account if you travel to Lagos and check your UBA account. So that is how distributed ledgers are. And whenever you update a transaction from one end, it reflects in every other UBA bank in Nigeria. So that's an example of a distributed ledger. So the blockchain is also an example of a distributed ledger, whereby, like I said, a distributed ledger is a database that is consensually shared across multiple sites, institutions, or geographies, accessible by many people. You understand? So the blockchain is accessible by many persons, and any mutation or anything that happens to the blockchain, any change you make to the blockchain, if I make a change on the blockchain from here, someone in the US can see that change on the blockchain. So that's one of the important feature of distributed ledger. So it doesn't have like a centralized place storage. So the storage are distributed. It's not just with one person and anything. So if one person in that whole connection of databases is destroyed, it doesn't affect the record of every other person. So if you look at this diagram here, you see where we have centralized ledger. So this guy, they are getting their data from this clearinghouse. So if anything happens to this clearinghouse, these four guys here will be affected. But look at this other guy on the right. This guy has their database. This guy has their database. This guy has, so they all have the same record. If anything happens to this guy, it doesn't affect these three guys. These three guys can still proceed with transaction without this guy being there. So this is the whole concept of distributed ledger. So I'll be moving to the next slide. So now let's look at the difference between Is that a question?
No, it's
Or a
just
message?
like a message saying that the slide be available for download.
Okay, yeah, the slide will be available. I'll send it.
All right, thank you.
All right. So the difference between so DLT means distributed ledger technology. So we are checking the difference between distributed ledger technology and the blockchain. So number one says the most important difference to remember is that blockchain is just one. Sorry, this is a typo. Blockchain is just one type of distributed ledger. Sorry, how did I get here? All right. So blockchain is just one type of distributed ledger. I'll correct this before I push the slide. So the blockchain is just one type of distributed ledger, which means there are many distributed ledgers. So blockchain is just one type of a distributed ledger. Now, blockchain is a sequence of blocks, but distributed ledger do not require such chains. Like I said, the banking system uses distributed ledgers. So, and banking system, they are not blockchains. So let's move to the next point. Distributed ledgers do not need proof of work and theoretically offers better scaling options. Removing the intermediary party from the equation is what makes why are there so many typos here? Sorry guys, let me just fix this stuff. Oh, I'm just doing this. Just give me, yeah. So first thing is this guy. Remove this guy. So while we are typing fast, distributed ledgers. Okay. Proof theoretically of avatar. So from the equation. Okay. All right, that works. Okay. So let's play from here. All right, sorry guys. All right, so I just saw one type again. Removing the intermediary party from the equation is what makes the concept of distributed ledger technology very appealing. So with the distributed ledger, there's no middleman. Like you don't have like one guy in the middle that handles everything. Everybody is their own boss and all of that. All records is being held by everybody. So if one person is affected, it doesn't affect the next person. That's what that line is saying. So distributed ledger does not necessarily need to have data structured in blocks. So blockchain have their data structured in blocks, but distributed ledger doesn't. So a distributed ledger is exactly how you can envision a blockchain. However, all blockchains are distributed ledgers, but not all distributed ledgers are blockchain. This point here is what you have to take home from everything and all of that. Like, I'm not very conversant with this slide too. So a distributed ledger is exactly how you can envision a blockchain. However, all blockchains are distributed ledgers, but not all distributed ledgers are blockchains. So yeah, that is basically it. And this is just a diagram showing how transactions happen in a blockchain. And yeah, so moving to the next slide, I want to be sure. All right. So before we move to consensus mechanisms, uh, it's time to get questions. Any question?
Yeah, I just have a quick question. Cass, can you hear me?
All right. Yeah, I
So,
can hear you.
it was about like just running back that statement again on like all blockchains being like distributed ledgers, but at the same time, like it's not being distributed ledgers. If you could clarify that for me, I would really appreciate it.
Okay. So what that means is before the existence of blockchain, they are distributed ledgers. So the idea of distributed ledger, now I want you to look at this stuff. Uh, look at this stuff. The most important difference to remember is that blockchain is just one type of distributed ledger, which means there can be a distributed ledger that is not a blockchain. For example, your Nigerian banks, the way you see all those banking halls, all those banking buildings and everything, the way they operate, the way the banks are interconnected, they are interconnected using this distributed ledger system. That is why whenever anything happens in your account in Lagos, it reflects automatically in your account in Abuja. The records are in the way the whole banking system is structured is using the distributed ledger system. If any banking hall or any banking building is burnt in Lagos, it will not affect the balance in your account. I don't know if you get that.
Yeah, I get that. I get
So
that.
now, so this is trying to let you know that all blockchains, every blockchain you ever know, whether Bitcoin, blockchain, Solana, Polygon, Ethereum, Binance Smart Chain, they all operate in the mechanism of distributed ledger. All of them make use of the distributed ledger technology. But not all distributed ledger technologies are blockchain. Example, your banking system. Do you now understand that?
Yeah, I do. That was much clearer. Thank you, Cass.
All right. Next question. Yeah, Tobiloba, your hands are up. Can I hear you?
Yeah, thank you very much. Am I audible? Okay.
Yeah, sure.
Yeah, so I have a question. So basically, as you said like the blockchain is sort of like a database, right? And like in the database, there are like a database of transactions rather. Or like in the database, there are blocks, and each block is like one transaction, right? There's like an author or somebody that keeps track of that, the movements of each blocks, and then tries to ensure that things in the chain of blocks
I'm
are
sorry,
good.
I'm
Is
getting
that what
confused.
yeah?
I'm getting confused. Can you come
Okay.
again? First of all,
Okay.
before we continue,
Mhm.
a block doesn't contain just one transaction. So
Okay.
that being said, you can ask your question again.
Okay. Thank you. So my
All right.
question is for every block, does one block come from like a specific person? Is that like a person making the transaction to the blockchain, or can several people make several transactions and that transaction gets compiled into one block and gets added to the chain of blocks?
Yes. So each block in the blockchain can contain a lot of transactions. All right. So let me just use a lot of transactions because I don't want to start going into stuff like what's it called, block size and all of that. So each block can contain numerous transactions, right? And it might be transactions from different persons and all of that. But the people that add these transactions to that block, they are the miners. So they pick these transactions from the main pool So and once they pick these transactions, they add it to the block, they add the transactions to the block and all of that. So yeah. Akikia. Sorry, I don't know if I answered your question.
Yeah, you did. Yeah, so the miners
All
and the
right.
mix. Thank you. Yeah.
Yeah. All right.
Yeah,
Akikia.
yeah. So, Cass, I wanted to follow up with I'm not sure it's dragging us back like too far, but you know how like earlier on you made mention of like the Genesis block and how like they are kind of like
Okay, okay. Wait. Calm down, please. I know. Let's just stick to what we have here, so that we don't. If you ask complex questions, you end up confusing others that don't know about blockchain for the first time. So if maybe the question you're asking will take us from the current topic, please, so you don't get other people confused. Are we good?
I don't really know like if it's take like. Well, my question was, I don't know like
Yeah,
now.
yeah, Ubi, I think I understand you, right? So Cass, I think you mentioned something. So I don't think it's taking you out from this whole topic. So there, when you started the call, like
Okay.
the presentation, you mentioned that you mentioned what's it called? Um, Genesis
Genesis
block,
block.
right? So I think that's what
Yeah.
it's referring to. Genesis block, for example, now might be something like somebody is hearing for the very first time. So I
Okay.
believe he wants to just get clarity on what exactly Genesis block is, so that they can
All
follow
right.
up from the very start before they proceed.
Yeah.
That's what I
All
believe.
right.
And
All right.
is that correct,
All right.
Obi?
So,
So like the reason I am asking this was because like the way Cass explained is that like our laptops, like our personal laptops, like they are the nodes, then like the thing that we're downloading, which is like the Ethereum client, like is the Ethereum client. Sorry, I don't want to mix things up. But like the way he explained it sounded like as if like my question was like, so what makes it different from like a linked list? You get what I mean? Like because of the example of this node like thing that Cass made mention of. If you get what I mean, I don't know if it's a stupid question, but that was the only
what
way I
makes
was.
it different from a linked list?
Yeah,
I don't know what makes it different from a linked list. So, but the thing is, so this is it. The way the blockchain works, right? Um, when you get your computer, which is obviously what we refer to as your node. Now, your computer is the node, but what actually makes it the node is if it has an Ethereum client connected to it. Now, once you have an Ethereum client installed in your computer, that Ethereum client now gives you access to the blockchain, which means you can download blockchain data. So, and you can either download an archive node or a full node. So, if you're downloading a full node, that means you're downloading everything from the beginning of when the whole transaction started, from the Genesis block and everything. So, and once you do that, now with that client you have installed in your computer, you now have the records every other node has. And that is what connects you to the blockchain. So anytime there is an update on maybe from your end, you write something to the blockchain, because of that client that every other person has, it will update their own node, and it will automatically fetch the data into their own system. So that is how the records are being updated. And if someone else updates the node, the blockchain, your client which you installed on your laptop will also fetch the data, like it will sync and everything comes back to your system. So even if your system gets damaged, it doesn't affect the record in every other person's system, because the record keeps updating and everything keeps syncing as data gets to the blockchain.
yeah. Thank you so much, class. Like that's way better.
All right. All right. Toby Loba, okay, let's hear you.
Yeah, I'm so sorry, but something just popped up in my head and I just thought to ask it. Money related, but like
Okay,
still related to the class too. So my own question is
all right.
all these Ethereum, all these Binance, all this Polygon, like what makes they are blockchains, right? I've always heard that they are blockchains. So what makes them different from one another if what they do is what you just explained now? Or is there like a general standard that a blockchain must have? Or what makes their own blockchains? What makes like Polygon different from maybe that file? What makes them different? Like are they doing anything different to make them unique? Or I don't get.
Okay, all right. So Ethereum is the big guy. Bitcoin is the big guy. Is the big guy, the father of all blockchain technology. But now, Bitcoin, the only thing Bitcoin does is transaction. Bitcoin only helps you transfer Bitcoin from one person to the other. That is the only thing Bitcoin does. But Ethereum was like, okay, how do we help people build softwares on the blockchain? How do we help people build on the blockchain? That's now where Ethereum came into play. So Ethereum coming into play. Now Ethereum has a problem. Ethereum is secure and all of that, but Ethereum is not scalable. Now when transaction, the number of transactions Ethereum blockchain is handling at a time spikes up, the gas fee becomes very high, and the time for processing transaction also increases. And this is, I don't want to be using terms that will lead to more questions. So I'm trying as much as I can not to use certain terms and all of that, because if I use them, it will lead to more questions. So now, this leads to what we call blockchain trilemma. And because of that, the gas fee, the scaling problem. Okay, yeah, Mr. Idris.
Yeah, sorry to cut you. I've heard gas fee, I've heard blockchain trilemma, I've heard, all of these things. So I think maybe you can just summarize like just like the difference without mentioning anything technical. I know we'll definitely get there,
Okay.
but just like giving like a very simple
Oh,
answer to the difference between Bitcoin, Ethereum, and Polygon. So then we move on.
okay.
So when we move on,
Oh,
then they will start to understand all of this trilemma, gas fee, and
uh,
all of that.
all right. All right. So Bitcoin just does transaction, only transactions, send Bitcoin from one person to the other, all of that. Ethereum is the guy that helps you build the centralized application. Without Ethereum, you cannot build the centralized application. Now, gas fee on Ethereum is very high because of the problem Ethereum has. So that is why guys like Binance Smart Chain, Polygon came out so that they can help build a blockchain that will minimize, that the gas fee will be less. So if you're building on Binance Smart Chain or Polygon, you'll be paying smaller gas fees for transactions and all of that. So that is just the difference. Let's just move ahead so that we don't spend time on this guy. All right. Okay. So let's proceed. So now we are moving
I
to
think you can share your screen back. You can make it bolder.
oh, am I still sharing my screen at the moment?
Yeah, you are sharing it. Like make it full screen the way it was before.
Okay. All right. Yeah. So okay, here we go. Now consensus mechanism. Before the best way you understand what consensus mechanism is to know the meaning of consensus. Consensus means agreement. Consensus means agreement. Consensus mechanism is just the process of which agreement is achieved in a blockchain, right? So that is how, for instance, we have different companies. Some companies have their policies on come to terms with things or how they agree to move ahead with a particular idea and all of that. And some companies too have different ways of how they move ahead with an idea. Maybe you have to submit it to this person will see it and all of that. So that is just what consensus mechanism is. Now, coming to the blockchain, the goal of consensus mechanism is to facilitate the process of agreement among participants of a distributed data system to guarantee data consistency. English is big. In this way, consensus algorithms achieve reliability in the blockchain network and establish trust between peers in a distributed computing environment. Essentially, the consensus protocol makes sure that every new block that is added to the blockchain is the one and only version of the truth that is agreed upon by all nodes in the blockchain. So consensus algorithms are designed to incentivize honest participants in the blockchain. What this is saying is, before a block is considered as a valid block, there are certain steps, there are certain things that need to be done by the miner that is mining that block. Now, if the miner has completed that process successfully and someone else verifies that these transactions are valid, consensus is achieved. So that block will be added to the blockchain. Just like I said, a company to initiate an idea, they want to work on an idea. It starts from the period where the idea was said or was initiated. Then they will now go through a process of if this idea is valid, if this idea will bring profit, what are the possible ways of generating profit from this idea, what are the loopholes. So you know all this kind of stuff. So these are just the process that will lead to that idea being executed and accepted as a valid idea. Same thing is applicable to the blockchain. You add transactions to the block. Before that block is added to the blockchain, you have to go through a process. That process is what shows that, okay, you have done your due diligence to ensure that this thing is valid. And once it is confirmed valid, it gets added to the block. And you get incentivized for doing the right thing, and you get punished for doing the wrong thing. So we have different consensus mechanisms. We have the proof of work. The proof of work is the godfather of blockchain consensus algorithms, which was first implemented on the Bitcoin network. Participants will only accept a valid block when the block hash is less than a target number known as the block difficulty. I know this part will lead to plenty questions. So now, the way proof of work works is it has already been programmed that there is a certain level, there's a certain number, a certain hash that needs to be achieved before we know that you've actually done your work on this particular block and all of that. So, and that's hash, okay, it's something like, let's say you place a range and you say any hash that is being hashed, the number must fall between this range. And if that number falls between this range, then this person is said to have done their work in order to add this block to the blockchain. So that is just what that stuff is doing. So when the hash of that block falls between that number, that is where proof of work is said to be done. And this hash is achieved by changing a particular number on the block called the nonce. Don't ask me about the nonce. There's a slide on this presentation that will look at the blockchain structure, what nonce are and all those stuff. So please just calm down. I know some of you have questions in your head already. So that is how proof of work works. So proof of work involves miners struggling very hard to solve a mathematically complex algorithm in order for them to get the hash that falls below that block difficulty. And once they get that number, that block will be added to the blockchain. And for you to achieve this, you need to have a whole lot of ASICs interconnected, so that it's like trying to change a particular number within few minutes of time. That is why you see binaries are competing with each other to solve that mathematical puzzle and all of that. So the next guy is proof of stake. Proof of stake. So many typos. Okay. So proof of stake involves currency holders staking some currency for the chance to validate a block. It works by selecting validators in proportion to their quantity of holding in the associated cryptocurrency. This is done to avoid computational cost of proof of work schemes. So what proof of stake is for instance, let's say 10 of us in this session, we want to be miners. And let's say for me to be a miner on Ethereum, I say, okay, I'm staking 30 Ether, and someone else take 10 Ether, someone else take 5 Ether, someone else take 2 Ether, and all of that. Now, the chances of me being selected by the proof of stake system to mine is higher because I have a higher stake to mine a block. But for proof of work, you are not selected. The ability for you to mine is based on your computational power, based on how fast your computer is to get that number that falls below that block difficulty. But for proof of stake, it is a system that selects who mines the block, and the criteria for selection is kind of proportional to the amount of stake you have. So the more stake you have, the more chances you have of being selected to mine a block. So the only difference between proof of work and proof of stake is the method of selection. Proof of work is you use your computer to struggle to get a number, but proof of stake is the system selects you based on your stake. Then the rest of the process is the same. Then we now have practical Byzantine fault tolerance. So Byzantine fault tolerance is a feature of a distributed network to reach consensus agreement on the same value, even when some of the nodes in the network fail to respond or respond with incorrect information. The objective of BFT mechanism is to safeguard against system failures by employing collective decisions. So there's something about the blockchain that, let's say, let me use us as example again. Let's say we have 20 persons on this call, right? And 20 persons on this call, someone a transaction came on board, and 17 persons said that this transaction is valid, but 3 persons said that this transaction is not valid. Now, the way the blockchain is designed to work is that the longest chain of agreement wins. So because 17 persons are more than 3, that 17 persons decision is what will be accepted. That is just how the Byzantine fault tolerance mechanism works. That's the layman or the most basic way I can explain it for you to understand without making any diagram and all of that. So then the one on the right says do research on others. Like I said, blockchain is all about research. So if I give you more information, you will get more confused as time goes on. So there are some things you have to find out by yourself, read, study, you know these things, you write about them in an article to prove that you know them. So we have other consensus mechanisms like proof of authority, proof of capacity, proof of importance, proof of activity, and delegated proof of stake. So you guys should do research on that. All right. So that being said, let's move to the next slide. I believe you guys are taking note too, because there are some things I will say that might make a whole lot of sense. And if you read some article, you might not understand them unless you maybe look what I say, because the way understanding stuff goes is it builds up upon something. So when you understand the basics, you can understand the complex ones and all of that. So here we have public, consortium, and fully private blockchain. So these are different types of blockchain. There are public blockchains, there are consortium blockchains. So consortium blockchain, they are like semi-public blockchains. They are kind of public and kind of private in a way. So they are in between private and public. And we have the fully private blockchain. So a public blockchain is a blockchain that anyone in the world can read, anyone in the world can send transactions to, and expect to see them included if they are valid. And anyone in the world can participate in the consensus process, that's the agreement process. Public blockchains are secured by crypto economics, the combination of economic incentives and cryptographic verification using mechanisms such as proof of work and proof of stake. Example of public blockchain, we have Ethereum, we have, let's just speak Ethereum. We have Ethereum, we have Bitcoin, they are public blockchain. Then consortium blockchain. The blockchain is a consortium blockchain. A consortium is a blockchain where consensus is controlled by a pre-selected set of nodes. Yeah. An example of a consortium blockchain, I think Binance Smart Chain is an example of a consortium blockchain, because the people that validate transactions, Binance, they are like selected set of miners that does that. It's not anybody cannot just come to the Binance Smart Chain and decide to be a node or a miner, all of that. I think they are a selected set of guys that does that. I think about 20 or so blocks. I can't really remember, but yeah, Binance should follow that consortium. Then we have the fully private blockchain. The fully private blockchain is a blockchain where right permissions are kept centralized to one organization. Read permission may be public or restricted, another typo, or restricted to an arbitrary extent. So these are the different types of blockchain. A private blockchain I know is Monero. Monero is a private blockchain, and yeah, there are many other private blockchains. So you can check that out as well. Okay, so let's move to the next guy. Here we have distributed ledger platform. So since the emergence of Bitcoin, which uses proof of work consensus algorithm, there have been different distributed ledger technology-based platforms springing up to solve scalability and decentralization issues. A comparison is given below. So yeah, this is the way this guy is. You have the blockchain, Ethereum, Hyperledger, Bitcoin, Corda, Repo, consensus algorithm, proof of work, proof of stake, DPFT, proof of work, DFT, and RAFT. I don't know this RAFT. I've not read it before. I don't know what it is. Repo protocol. So network size, global, limited, global. So you can just look through this guy, and once this guy is here, you can just look through. You can see different blockchains and the consensus mechanism they use, protocol implementations. The Ethereum is written on Go. Ethereum client was built with Go, C++, Python, Haskell, Java, Rust, Ruby, JavaScript. So these are just all these guys about these guys. So sorry I use guy a lot. Okay, so now it's time for question before we move to the next big guy. This is a big guy. All right, so question time. Hello, am I still audible?
Yeah, we can hear you.
All right.
Yeah, we can hear you. I think there's no question for now or something.
Awesome. Well, all right, so let's move to the next guy. So everybody buckle up. This guy is gonna get really interesting.
Okay, so somebody
Write
is
your
raising
questions
up his
down as
hand.
we proceed.
Abdullah.
Okay.
Yeah, Abdullah, please, you have the floor.
Can you check the chat? I just type something.
Oh, okay. Let me check. Let me see. Okay. If the longest block in the blockchain determines what's added, I don't know if I'm correct, but you get, I don't know if I'm correct, but you get the guess. What is the assurance that fraud can't be made? Awesome, awesome, awesome. All right, so the reason why fraud can't be made is because the way the blockchain is structured to work is nobody knows anybody. You don't know what the next person is sending. You don't know. Nobody knows anybody on the blockchain. So, for instance, now I'm being paid to do the right thing. Why will I want to do the wrong thing? And if I do the wrong thing, all my computational power, the whole money I spent in ASICs and the electricity and everything, I will lose them. I won't get, let's say that ether that will be given to me after successfully mining a transaction. So that is why if you look at this guy, let me show you something. If you look at this guy, they say public blockchain are secured by crypto economics, the combination of economic incentives and cryptographic verification using mechanisms such as proof of work and proof of stake. Now, these incentives are being given to you to do the right thing. For instance, one person cannot manipulate the blockchain to have the longest chain, because for you to do that, you need 51% of computational power, which you cannot get. You cannot achieve it. So, because of these economic incentives, every miner on the blockchain wants to do the right thing. Every miner on the blockchain wants to ensure that the transactions they are adding to the blockchain are valid, so that they will get their incentive. They will get that Ethereum that is being given to them for successfully mining a transaction. So since every miner wants to do the right thing to get incentivized, the few ones that didn't do the right thing will lose and all of that. And there's no how, you don't know this person, there's no how you now chat this guy, hey bro, what's up? Let's do the wrong thing. Hey bro, what's up? Let's do the wrong thing. How will you chat all the miners so that you guys will do the wrong thing? There's no how you can do that, because you don't know them. You guys don't know each other. So you just have to do the right thing to get incentivized.
All right. Thank you. I really appreciate it. I think I get it now.
All right. So let's proceed. All right. So guys, this part is really, really important. What we are trying to, this section of the whole stuff is very, very important. Now, before I continue, there are a lot of blockchain developers. There are a lot of blockchain developers and smart contract developers. But what makes you different from another smart contract developer is depth. Depth. And you can write smart contract, but when it comes to certain complex manipulation that has to do with hashing, using KEKAK 256 to do this and that, you get stuck. And that is where depth comes in. So this part we are about going into now, if you understand this part, this is your journey to start getting what we call in-depth knowledge and rare knowledge about the blockchain. All right, without much talk, let's start. So a cryptographic hash function. A cryptographic hash function is a mathematical function that converts a numerical input value into another. wait, numerical. That word numerical means a number. No, cryptographic hash functions can take in anything. It can be number, it can be text, it can be anything. So it's that numerical. That word, I'm very sensitive to words. So a hash function is a mathematical function that converts a numerical input value into another compressed numerical value. Okay, compressed numerical value is correct. So into another compressed numerical value. The input to the hash function is an arbitrary length. It's an arbitrary length, but the output is fixed. Okay. So I'll have to show you guys something for you guys to understand what cryptographic hash functions are. So permit me to exit this guy. Let me go to my browser. I think I have it open, and there's a reason why I opened it. So yeah. All right. So there are different types of. Can you guys see this screen? Hope this one is not tiny as well.
It's tiny.
Yeah,
Oh,
it's so
wait.
tiny.
Okay, let me
You
see.
can zoom in.
Let me see. Let me zoom in. Command.
Yeah, zoom in on the page,
Download
right?
it.
Yeah, or make the page big,
Yeah.
then zoom in.
All right. So is this okay?
Still tiny. Okay, it's okay now.
Yeah, yes.
Awesome. All right. So if you look at this guy now, these are different hash functions. You have the SHA-256. Wait, what is it? What is SHA-256? SHA-256. This is the hash function Bitcoin uses, if I'm not mistaken. You have the SHA-256. You have the KECAP-256. This is the hash function Ethereum uses. So now, before we go ahead, let me come back to my slide. Let's just look at the properties of a cryptographic hash function. So if I'm extending this guy, you'll be able to sync with what I'm trying to do. So let me play this guy again.
Yeah, can you copy and paste that link on the chat? I mean the
Yes,
link
yes,
to
yes,
that.
sir.
Yeah, please just drop it on the chat. I'll also
All right,
share it on the Discord, guys, so we don't lose track of it after this call.
all right. So I'll do that once I get to that browser. So properties of cryptographic hash functions: non-reversibility, also known as a one-way function. A good hash should make it very hard to reconstruct the original password or the original text from the output of the hash. So this means when you put in, let's say you put my name Cass in the input and it gives you a text, it should be very hard for you to carry that output, that hash output, to get back Cass. So that is one property of a cryptographic hash function. It's very hard to reverse engineer the hash to get back the value. Number two is that cryptographic hash function has this diffusion or avalanche effect. Now, what this means is a change in one bit of the original input will result to a change in the entire output. If let's say you put Cass and you later add just letter W, it will change the entire output. It won't just change a section, the entire output will change. Then determinism. So that means it should be deterministic. A given password must always generate the same hash value on a cipher text, which means if you put Cass in your input and it gives you a particular output, anytime you come back and put Cass again, it is that same output it must give to you and not something different. Then the next guy we have collision resistance. It should be hard to find two different passwords that hash to the same cipher text. For instance, you put Cass in the input and it gives you a particular output, and you now put Joe in that same input and it gives you that same hash text that Cass gave to you. That should never be possible in cryptographic hash function. Then the last one is non-predictable. The hash value should not be predictable from the password. So you can never, if I give you the hash, you can never say, oh, this hash is the hash that hashing cats will lead to. So these are the properties of the few properties of cryptographic hash function. There can be many more and all of that. So let's go back to this guy, to that browser stuff. So now this is our hash. So this is our guy. So I'm putting cats. So you see, take a look at this guy. This guy starts with B2B and here ends with 828. Now let me just put W. You see that everything has changed. Everything has changed. So this is the avalanche effect we are talking about, right? So this is the avalanche effect. So, and let's say we do hello, and hello gives us this. So I'll copy this and I'll paste it here. Let's see. Let's confirm if it's the same thing, right? I'll paste this guy. Now I'll come here and I'll say hi, and I'll type hello again and see if it will give us the same thing. So look at, we have 1C8AFF. This is 1C8FF, and we have DEAC8, and we have DEAC8. So this is what it means that it is deterministic. So anytime you put hello, it will always give you this thing, provided you're using the same hash. So currently the hash we are using is KECAP256. You can change your hash here by clicking any of these hash. You can use SHA-256 and all of that. Now this is how cryptographic hash function works. And remember that this is why I said this numerical input that was used in the definition is not really correct, because you can also hash text and any other stuff. So numerical means numbers, but you see, we can hash text as well. So this is it, and this is this about cryptographic hash functions. So before we move to the next guy, we are still on cryptographic hash functions though. So let me copy this stuff and send to the. Okay, someone's hand is up. Please, don't worry. Just note your question. I'll give room for asking questions. Okay. All right. Just note your question. Write it down. We are still on cryptographic hash functions. Someone say my brain that defeat me. You have not started, though. All right, let's proceed. Okay. So, moving to the next guy. Okay. All right. Let me play this guy back. Okay. So, examples of cryptographic hash functions. We have cryptographic hash functions are widely used in cryptocurrencies to pass transaction information anonymously. Example, Bitcoin, the original largest cryptocurrency, uses SHA-256. Okay, I was correct. So uses SHA-256 cryptographic hash function in its algorithm. Similarly, IOTA, that's Internet of Things, has its own cryptographic hash function called call. However, hashes have other applications in the real world apart from blockchain here. These are some of the common cryptographic applications. Password verification. Now, for those of us that are coming from the Web2 ecosystem, where you're working on the back end, so a user signs up. If a user signs up, let's say I type my password as password. You can't carry that original text and save it in your database. So you have to hash it using either MD5, SHA-256, or any of those stuff. You have to hash the password first before saving it in the database, so that if peradventure your database gets exposed or gets hacked, all the password the person that gets access to it will only see is the hash, not the actual password. So, and whenever you want to log in, as you type the password, you still use that same hash you use in hashing the password when signing up. You use that same hash to hash that password. Then what you compare is the hash of the password the person is putting in and the hash that is saved in the database. And once they match, successful login occurs. So one of the real world application of cryptographic hash function is password verification. Then the next one is signature generation and verification. So verifying signature is a mathematical process used to verify the authenticity of digital documents or messages. So a valid digital signature, where the prerequisites are satisfied, gives each receiver strong proof that the message was created by a known sender, that the message has not been altered in transit. So a digital signature scheme typically consists of, so a digital signature scheme typically consists of three parts: a key generation algorithm, a signing algorithm giving a message and a private key produces a signature, and a signature verifying algorithm. So first you generate the key, second you sign the message, and thirdly the part where that message is being verified that this is the authentic message and all of that. Then Merkle trees, a technology used in cryptocurrency, is a kind of digital signature. Yes. So we are not going to talk about Merkle tree. There's an entire full slide for Merkle tree. So it just came in here, so overlook it. So verifying file and message integrity. Hashes can be used to make sure messages and files transmitted from sender to receiver are not tampered with during transit. The practice builds a chain of trust. For example, a user might publish a hash version of their data and the key so that the recipient can compare the hash value they compute to the published value to make sure that they align. Yeah. So this is just real world example of cryptographic hash functions and all of that. So moving to the next guy. Public key cryptography. All right, before we start public key cryptography, let me entertain questions because this is another sweet guy that I like. I'm getting like 5 notifications at the same time. All right, let's go. Who is the first person? Ola, please go ahead.
Israel, yeah, well done. All right,
Yeah.
thank you very much. Okay, so my question is, I don't know, let's say simple. Do I know of hashing a password before saving it in the database? I don't know how that is done. I'm a front-end developer. So my question is, this cryptographic hash function, is it more like a function we are writing ourselves? Will we be writing the code or something? Or we are still getting to that part? Do you get my question? Can anyone hear me?
Yes, we can hear you. Cass, you're on mute if you're saying something.
I think his mic is muted.
Yeah. So sorry, I was drinking water. All right. So you don't have to write the function. The function is already inbuilt in the blockchain. So all you just need to do is call the function and pass the value you want to hash, and it will hash it for you. Just the same way this guy I showed you here. Where is it? You see? Where is that stuff again? Okay, yeah, this guy. See this guy? This function is already there. It's already in Ethereum. It's inside Ethereum. If you're writing smart contract, I just need to this kecap 256 and you pass in what you want to do, and it will hash whatever value you pass in there for you automatically. So you don't need to write any function that will be doing hashing for you and all of that. Yep. So
okay.
I don't know if I answered your question.
Yeah, I get that perfectly. Thank you.
All right, next guy, Akikia.
Yeah, Cass. So my question this time around is like we've been talking on like hashing or hash functions. Like with hash functions, are there any side effects? That's my question.
Side effects. There are no side effects. I've not experienced any side. In fact, there are no side effects. They are just cool and sweet to go with.
Okay, that's the only thing I had to ask.
Muhammad. All right, shoot.
Yeah, good evening. Sorry. So my question is not actually about the hash function. My question is actually about the nodes. Yeah. So basically, for me, I used to see the blockchain as a database. Like it's a database, right? But for Web 2, you have to your database is in like zeros and column and blah blah blah. But this for Web 3 now for the blockchain technology is a block and data gets added to the block and it turns to a blockchain. So I wanted to ask these nodes that are participating in the blockchain, they as in they have access to all the data that are added to to the blocks, right? So what happens to this data? Like do they have access to do anything to this data? That's my question. I don't know if you get that's for the nodes that are participating in that particular blockchain ecosystem. Do they have access to do anything to the data that are in them? Do you get all the data that they have access
No,
to? Do you understand?
no. Yes, I get you. They can't manipulate those data. They can't. All they just do is verify, okay, get this transaction, add it to the block, and someone verifies that, okay, these transactions are valid, and it gets added to the blockchain. And once all that is done, those data cannot be mutated. You can only fetch them, use them let's say, just see, for instance, let's look at Facebook, or sorry, let's look at Twitter, for example. Now, if you want to build your app, using Twitter API. Twitter will give you access to certain data and all of that. You can just get those data, use it for your app and all of that. So if you want to build something on the blockchain, let's say you have access, for instance, there is a node provider that gives you access to an API that can fetch records from the blockchain. You can just use the data and build your app, but you can't modify it unless maybe there's a smart contract that you wrote that should modify a particular state according to how you specify it. But miners can't modify those data. They can't. All they just need to do is to verify the transaction, add it to the block, and they are good.
All right, thank you.
All right, you're welcome. Okay. All right, let's proceed.
Yeah, like I can't hear also. I think Cass is muted or is drinking water.
Yeah, I also cannot hear anything. I think the speaker's
Someone
mic is
muted
muted.
me.
So let's wait.
Hello, someone muted me. Someone muted me. I didn't mute my. I can't remember muting myself. Yeah, someone muted me. So please
Oh, well,
don't mute
sorry
me
about that.
again.
Who did
No.
that?
All right.
Sorry about that.
All right. So as I was saying, uh, I don't know where I stopped. So let me just start from the beginning again. As I was saying, this part of this session we are about to start, this is the part that controls almost everything that you need to know about the blockchain. Now, ranging from how private keys, public keys, wallet addresses are created, ranging from how transactions are being signed and how the blockchain knows that, okay, this transaction is being signed by this particular address. Everything is going to be covered in this section now. So hold your popcorn. In fact, don't hold popcorn to distract you. Pay attention and let's ride on. Okay. So let me play this guy again. Yeah. All right. Awesome, awesome. So public key cryptography. Public key cryptography or asymmetric cryptography, an encryption scheme that uses two mathematically related but not identical keys, a public key and a private key. Unlike symmetric key algorithms that rely on one key for both encryption and each key performs a unique function. The public key is used to encrypt and the private key is used to decrypt. So first of all, before we continue, I want you to understand that the blockchain as a whole till now has nothing to do with encryption. Yes, write your question down. You ask me question on that part. So I know you ask me question. Me, I know. So the blockchain has nothing to do with encryption. So they are just trying to teach you something about public key cryptography. So let me start again. Public key cryptography or asymmetric cryptography is an encryption scheme that uses two mathematically related but not identical keys, a public key and a private key, unlike symmetric key algorithms that rely on one key to both encrypt and decrypt. Each key performs a unique function. The public key is used to encrypt and the private key is used to decrypt. In Ethereum, we use public key cryptography to create the public-private key pair. This is where public key cryptography is used in Ethereum, not in the encryption and decryption part. In Ethereum, we use public key cryptography to create public-private key pair. Pair because public key is derived from private key, and together they represent an account by providing a publicly accessible account handle called an address. Are you guys getting this part now? So it is computationally infeasible to compute the private key based on the public key. Because of this, public keys can be freely shared, allowing users an easy and convenient method for encrypting content and verifying digital signatures. Encrypting content cancel for encrypting content and verifying signatures. The private keys can be kept secret, ensuring only the owners of the private keys can decrypt content and create digital signature. Decrypt content cancel for Ethereum. But this one now, just know that with private keys, you can decrypt and encrypt and all of that. But for Ethereum, the blockchain itself, it is for signing transactions and all of that. It's not for encrypting and decrypting. All right. So look at this part I highlighted, the yellow, the blue, and the green. This is because these parts are very, very important. Public key cryptography is used to control ownership of funds in form of private keys and addresses. This is where public key cryptography is important in blockchain, not encryption and decryption. Private keys are at the heart of all user interaction with Ethereum. In fact, account addresses are derived directly from private keys. I don't know if I have a slide that shows how that is done. Okay, I think I do, yeah. So we'll talk about how those things happen. So the main business application for public key cryptography are digital signatures and encryption. And the part that concerns blockchain is digital signatures. So let's go. Digital signatures, content is digitally signed with an individual's private key and is verified by the individual's public key. Encryption, content is encrypted using an individual's public key and can be decrypted with the individual's private key. Security benefit of digital signatures. Assuming the private key has remained secret and the individual it was issued to is the only person with the access to it, digitally signing documents like emails offers the following benefit: authentication. Reasons is because I signed it, so it's authentic. It shows that I'm the one that signed this guy. non-repudiation. Since the individual is the only one with access to the private key used to apply the signature, he or she cannot later claim that they are not the one that applied that signature. I cannot sign a transaction like I want to send Ether to you and I sign the transaction. Later I'll not say, oh, I'm not the one that authorized the transaction to send Ether to this guy. No, no, no. You can't come back and do that because you're the one that signed that transaction. Integrity. When the signature is verified, it checks that the content of the document or message match what was in there when the signature was applied. Even the slightest change of the original document will cause the check to fail. So this is the security benefit of digital signatures. So let's look at, oh, I made a mistake. I copied this stuff twice. So digital signature here is supposed to be, encryption. Sorry, I'll edit it. So you can read up this encryption part, but our focus for this stuff is that digital signature because blockchain is focused on digital signature. Nothing, blockchain has no business with encryption and decryption. Now, let's go to ECDSA. Elliptic curve digital signature algorithm. Please, guys, pay attention. This is the algorithm that powers the Ethereum blockchain. This guy you're seeing now, and you will see it in so many blockchain tests, interview questions, and all of that. So elliptic curve are a specific flavor of the asymmetric or public key cryptography. So pay attention. We are talking about public key cryptography. Elliptic curve is just one type of public key cryptography, one flavor of public key cryptography based on the discrete logarithm problem as expressed by addition and multiplication on the point of elliptic curve. So what elliptic curve is just a graph with x and y axis. So a point in that graph is where this mathematical multiplication occurs that converts your private key to your public key. It is the elliptic curve that converts private key to public key. That is why it is one of the most useful algorithm in the blockchain, Ethereum to be specific. So they are widely used in the blockchain technology because of three reasons. Their computational performance is economical compared to a lot of other algorithms. The keys that are generated are relatively short. Bitcoin started it, so most new blockchain projects have copied it. Now, let's look at how public key and address are being generated. Pay attention to this part. This thing is so sweet. I love it. Given a private key, a public key can be derived or calculated using the elliptic curve multiplication. Now, this is the elliptic curve multiplication formula. K, I've clicked something, sorry. K is equals to K. This thing is not times. This is not times. So this is not times. This is, look at it. This is a special multiplication operator, the elliptic curve multiplication operator. It's not your normal multiplication symbol you know in your basic math. So K is equals, big K is equals to small multiplied G, where K is your private key. Small k is the resulting public key that you will get from this private key. G is a constant point called generator point. Like I said, elliptic curve is like a graph of x and y axis that has different points, and those points can be randomly picked. It's not specific, they can be randomly picked. So once that point is picked, this multiplication occurs, and that is why, since it's randomly picked, that's why it gives you a different what is it called, private public key. Now note, it is easier. Oh, if I click just one small thing, this thing will take me to another slide. Okay, note, it is easier it is easier for a public. Oh, it is easier. Okay, I get what is missing here. It is easier to derive a public key from private key, but you cannot calculate the private key from public key. Take note of that. Now, the last 20 bytes of the KECAP 256 hash of your public key with an OX prefix is equal to your account address. Confusion is everywhere now. I know that confusion is just everywhere. Just note your confusion. Don't worry. Meku trees. Okay. So I think I can take questions now before we proceed. Time to tell me your confusion. Is there no confusion? Omo, this is making sense. Let me proceed then.
We choke. Oh.
Okay, Akikia. Okay, Akikia. All right, go ahead. Let me hear you. What's
My
the
question,
time? Okay.
yeah, my question is
yeah, go ahead.
It's because of that last statements that you made. If you could show us like the practical example of that, the last 20 bytes. Is it just like the last like 20 characters there?
Okay. Okay. So let me how can I get where can I get a public key? A public key now. So now let me show you something. Where is this guy? So before I proceed, let me answer this guy's question. Now, supposing this, let's say this stuff now I'm typing here is our public key, right? Are you paying attention?
Yeah.
Let's say this stuff I typed here is our public key. And we are hashing this public key using KECAP 256. Look at it here, KECAP 256. We are actually using KECAP 256, right? Are you there?
Yeah, we are.
Please, Akikia, keep your mic on. So I want to be communicating with you. So we are hashing this guy using KECAP 256, right?
Yeah.
So let me go back to this slide and see this stuff. Where is it? This last statement here. The last 20 bytes of the KECAP 256 hash of the public key with an OX prefix is equal to your account address. Now, with this, the last 20 bytes, now we are going to copy this stuff. Let me copy it and paste it here. So pay attention to what I'm doing. So now I'll count from back the last 20 bytes. I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Now this is our last 20 bytes. Now I've copied it, Control C, then I'll Control A everything, remove it, and I'll paste the last 20 bytes with an OX prefix in front of it. So let me do 0x. This is an account address. Do you get it?
Yeah, well, you counted to 40. So let me
Yes.
count. 2, 3, 4, 5, 6, 7, 8, 10.
So now the second one is correct. The X is a small letter X, not the capital letter X.
Yeah, my confusion now is like for the fact that you counted, they said 20, or is it like the size difference now that is getting me confused, or the mathematical like
Okay, so now this stuff, two of this character.
Yeah.
2 of this character is 1 byte.
Okay, two of it is 1 byte.
2 of it is 1 byte. Two
Okay.
of it is 1 byte. So they say the last 20 bytes, that means it will be the last 40 characters.
Okay. Okay. That is much
Is
more
that
clear.
clear?
Yeah. Thank you, Cass. And you just added
Awesome.
OS.
All right.
You just
Just
added
add
OS.
OS in front of it.
Okay.
Yes. Zero and small letter X in front of it, and that's how your guy is gotten.
Mm.
All right. So who is Nwo Okporo? Please go ahead.
Yeah, good
I'm
evening,
sorry.
everybody.
Sorry. I'm murdering your name. Just go ahead.
It's allowed. Okay, can you guys hear me?
Yes, I can hear you.
Okay, I'm asking. I'm sorry. I want to ask. You called the name of that sign. What did you call that sign? That
Who
you said
signed?
it was not multiplication. You said it was not multiplication. You gave it a name.
Okay. See the name. What it's called is. Look at it. This star is equal to it's the special curve multiplication operator. So it's this ECDSA curve multiplication operator. That's what they call it. So it's just there, but it's not performing the normal multiplication you know in math.
Okay, so what is
Because
it doing?
this is the guy that performs the whole stuff, just know that it is a special multiplication operator in ECDSA, and you cannot use, see this thing now in your head. You can just say, okay, since the private key is equal to this, that means if I put in my public key, I can reverse engineer this math to get my private key. Baba dash, it will never work, because this thing is not the normal multiplication you know.
Okay, thank you very much. Understood.
Oh, awesome. All right, so please let's proceed. We are running out of time. Okay, so where are we? We just got to this sweet part of this, as in this section, this second section from cryptographic hash functions downwards. We are just dealing with the sweet part. There's a question I was expecting, but nobody asked, so let's proceed. Okay, so Merkle trees. This is another lovely guy. And what makes you a super sweet, lovely, smart contract developer that can do amazing things is the understanding of Merkle trees, not just for blockchain, but how it works. Because there are times where you'll be asked to build a platform that users will come to claim tokens given a particular address. It is things like Merkle tree that are used to verify whether this user
I don't know if it's my network or I think Cass is rugging.
I don't think it's only you. Even me too. I'm experiencing it.
You say what?
I thought your network was
We
rugging.
can't hear you, sir.
Oh, but you can hear me now, right?
Yeah,
Yes,
okay.
yes, but previously we could not hear you.
Awesome. Sorry, I don't own any of these company. I'm using Intel and Airtel at the same time, so I can switch the area over there. All right. Let me continue. Merkle trees are a fundamental part of what makes blockchain tick. Although it is definitely theoretical possible to make a blockchain without Merkle trees, simply by creating a giant block header that directly contains every transaction. But if all the transactions in a blockchain is inside one block header, then imagine all the block transactions since the Genesis blocks, how many years ago. It will be hard, and it will be it will pose a very large scalability challenge for you to query data from the blockchain, because all this data will be in one block, and you will just be looping through series of records to fetch data. So, that will be very, very hard. So doing so poses large scalability challenges that arguably puts the ability to trustlessly use blockchain out of the reach of all the most powerful computers on the long run, as in long term. That means if your system doesn't have very high capacity or speed or RAM or processor, before the system gets a particular record from the database, the system will run out of resources to process that transaction. So Merkle tree is a special kind of binary tree used to encode large chunk of data. The cool thing about Merkle tree is that they build up from bottom up to allow you verify if some value is present in the tree or not, without having to loop. So sorry guys, let me respond to something. Just give me so right, yeah, I'm back. So the cool thing about Merkle tree is that they build up from bottom up to allow you verify if value is present in the tree or not, without having to loop over the entire element. Merkle tree is a type of hash tree in which each leaf node is labeled with a cryptographic hash of the data block, and each non-leaf node is labeled with the cryptographic hash of the child node, blah, 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 blah. By creating the data structure that is built of cryptographic hashes, the entire tree is cryptographically authenticated, because changing one piece of data will change the root hash of the tree. We can use the root to efficiently verify every item of the leaves, and okay, only a subset of data does this. So let me explain this guy. So am I on the next slide? Go to the next slide. What's happening?
No, you're still on the Merkle tree.
Yeah, I'm trying to go to the next slide and this guy is not moving. Okay, okay. Yeah, I know why. I was in another page. So now, one thing you need to understand is that, like I said, a block can have many transactions. A block can have many transactions. So, and that is why it's easier to verify. It's easier to verify transactions on the blockchain, because transactions are tied to a particular block, and these transactions are created using this Merkle tree. For instance, let's say we have a block with 8 different transactions. So transaction 1 is hashed, so you have the hash of each of the transactions. Now, these 2 transactions will pair to give you this hash 12, hash 1, 2, and this one will pair to give you hash 3, 4. This one will pair to give you hash 5, 6. This one will pair to give you hash 7, 8. Then this one will pair to give you this hash. These 2 will pair to give you this hash. Now these ones will pair to give you this last one. And now this is called the root hash. This is called the root hash. Now, if you want to verify whether this transaction is part of this block, all you need is this hash and this root hash. Once you pass this guy and this guy into your verifier, it will tell you whether this transaction exists in this Merkle tree or not.
Cause I'm not sure your cursor is actually on that thing. When you say this guy and this guy, I don't even know which one you're talking about.
Are you seeing my cursor now?
No, not moving.
Are you sure? Please, if
I'm not
there
sure.
anybody, look at my cursor is on hash 34.
Yeah.
Are you
Okay,
seeing it?
it
can
showed
see
for a
it
while.
now.
It showed for a while.
You can, but it's tiny. You can see it's but it's
Oh,
tiny.
I don't know how to make it big. So this is, so let me just call the hash name. So just understand that Merkle tree is like a tree of transactions building up to one particular node. So this is a leaf, this is a leaf. Each of these hash 1, hash 2, hash 3, hash 4, hash 5, they are all leaves. But when hash 7 and hash 8 joins together to give you hash 7, 8, it becomes a node, a leaf node. When hash 5 and hash 6 joins to give you hash 5, 6, it becomes a leaf node. And the last node is called the root hash. And with this root hash, you can verify whether hash 1 exists in this block and all of that. Now, let me show you an example of how Beku-tree is used on the blockchain. So let's see. We have like uh, 1, 2, 3, 4 more slides to go. So I want to beg, is Mr. Idris on this call? You just give us like, I don't know if we can get like extra 30 minutes to finish up, because some of these concepts need to be properly explained, and I don't know how to do it. Wisdom. Okay, let's continue. We'll stop anywhere we stop. All right. But for the sake
Yes,
of
please
understanding,
go
I
go
don't know.
on, please. Please go on.
All right. All right. So now let me show you how Merkle-tree is being used in the blockchain. So let's go to Etherscan. Let me open Etherscan. So Etherscan is a block explorer used in checking.
Sorry, I can't hear anything again now.
Is it me or I'm not hearing anything anymore?
Yeah, I think Cass is rolling.
Same here, actually.
Oh, okay.
Cass,
Just hold on for him. My business network. At this point, I feel like it's Nigeria factor, Nigeria network. Nigeria has happened to everybody. So let's just hold on for him. Hopefully. So how has been the training? How is it going? How is it going? I know
It's
a lot of
going.
people are confused.
From this side, it's looking very interesting. But I don't know. There's this thing that if you have too many information input in your head, it may be too much. I think the ones we have, maybe we should just go and because we still need
I
to
can
research on it.
imagine. Yeah, I've been there, but
Then
the,
at
the, the
least
secret is just be as calm as possible and be open to accept all the information. Make sure you're not confused, yeah. And jot as many things you can jot down because you're going to actually go back, probably listen to the recording, go through the slide to understand. Time is not on our
exactly,
side, but I know it takes a lot. I remember when I first took
exactly.
my blockchain class as well. It was like, what are these people saying? How did you people get this thing? Where is it coming from? So it's normal. So let's wait for him. I don't know what's wrong. Let's wait till like 2 or 3 minutes and expect him to be back. So Idris is trying to reach him.
Is our speaker under pressure?
It seems pressure until we're everywhere.
Oh, good.
Getting where, sir.
So I hope everyone is jotting something down.
Okay, he said
Yes,
his
Jonah
PC.
is now.
He said his PC restarted unexpectedly.
Oh, okay. I
Yeah,
said it's Nigerian factor.
yeah. So it's coming up shortly, like shortly. So once it comes up, it will just round up. I will try as much as possible to get like what's it called? The slides, number one, and also prepare this video for it to be ready for anyone that still wants to like go through the presentation. But of course, we'll also share the slide with you, so you can check the training resource channel that was created um, to see like a few resources or a few links that was shared in the chat here, so that probably it could be useful for you and spend more time on your own to go through these things or try to Google some of the terms that you might have heard today that you don't understand. So we specifically designed that after this call, you'll be taking like next week off for you to read on your own and just to digest few things because you totally understand that people will be hearing like new stuff from the presentation today. So what you just need to do is get the slide, go through it on your own. If you find anything you don't understand, you can just Google it out. Or if you find a resources also that you feel can help like anyone here to benefit, you can of course share on the training resource channel. And yeah, so while the election, all of this thing is going on, you're just there reading up on a few things to understand the basics. Yeah, so I think similarly you have your hands on, up rather, you have the floor.
Thank you very much. Concerning the jottings,
Yeah.
Kemi talked about the other time. I think it will be better if we have a video. That's when we can go back to because for me, if I want to jot and also listen to what he's saying, I could be missing a lot of things. That is one. Secondly, I want to appeal with my colleagues on call to please minimize their interaction on the chat session. Even if you don't want to put your mind there, some things just pop up blocking the presenter's view on my screen. That is one. Then secondly, these important links you are sending to us, they just mix up with a lot of chat and we can't just differentiate them. Gives a lot of problems. So I would like us to look into that. Thank you very much.
Yeah, thank you so much for that. So all the links that I shared here, including the one I think somebody shared um, for this, what's it called, the cryptography hashing thing. I've also shared it on the Discord. So I know that once we end this call, this chat, everything here will disappear. So I have everything on that training resource channel, and I believe everybody can access that channel to go through those links. Thank you for for that and for the chat thing. I believe as we move on, like everyone could understand and relate to what you just mentioned, we will do better. And then yeah, thank you so much for that. Really appreciate.
Thank you very much.
Yeah, I think he's back. Um, hello, Cass. Are you back? Okay, you're on mute if you're saying something, Cass. Okay, let's see. We're about to wrap up actually. So, all our calls is planned to, just take 2 hours during the call, unless there's like a reason for us.
Hello, can you hear me?
Yeah, we can hear you now.
Uh, I'm very very sorry. I don't know. I've not shot this laptop for like 2 months, so he just had to remind me that I've not shot it that. So it just restarted unexpectedly, and it's kind of lagging because there are so many tabs everywhere. So that I'm really really sorry. I'm very very sorry. So I don't know. Can we continue? Let me just quickly wrap up everything. I don't know if
Yeah.
I'll be the one to take you your next class, so I really beg that we continue.
Yes. So we just have like a discussion. So people are learning quite a lot from what you've been talking about, and it seems like they are loaded with tons of information. So one thing first is we would need the slide. The other thing is just try and wrap up. And if there's any other thing we need to step in, then we can find a way to do that. And they will be having like enough time during, next week to go through the slide, read up on their own. So if you would like, or if you would be available for a Q&A session, just to wrap up or whatever, just to help people that are learning, then we can just schedule like a quick call, and you can just quickly jump on it. That would be dedicated for Q&A. This is optional, right? This is voluntarily, basically, like if you wish, right? So yeah, that's it.
All right, sure, no problem. Like, yeah, I love to see people learn and all of that. So yeah, I'll be up for the Q&A.
Yeah, so I think you can, if you want to still share your screen, then you can share your screen and wrap up. Then we can take it from there next week.
All right, okay. So let me just share my screen. I'm really sorry, guys. Uh, I used to think Mac is one of the best computers out there. I don't know these guys look at me. This is the first time I'm experiencing this. Okay, so I'm sharing my screen now. Just wait for it to come on. So all right. So can you guys see my screen?
Yes, but it's a little bit tiny.
All right, I'll maximize it.
All right.
I'll maximize it. So let me just yeah. So I wanted to show you guys how Mercury is being used before this guy went off. So let me quickly go to a task scan. So we just see this guy. Uh, please, guys, read up on Mercury 3. It's a really, really cool concept. You need to understand it is what makes the blockchain work the way it is. It's working, and it has a whole lot of applications in DeFi and all of that. So okay, let me maximize this guy. Uh, So can you see this Etherscan screen? Is it big enough? Hello. Okay, let me go one more.
No, no.
Okay, I'm going one more. Easily. So can you see it now? Hello.
If you can still come a bit more.
A bit more. Okay. Ah,
No, I
this is
think
good.
you need to be
It's
patient.
okay like this. It's okay like this.
So
Okay.
there's a network lag. So when you zoom, you
Okay.
need to wait for a while for it to reflect on other
All
people's
right.
screen, especially those that are using Glow. Sorry.
All right. All right. So now, guys, look at my screen. You see what we have here. We have latest blocks, and these are different blocks. This is block. This is a block. This is a block. This block was mined 14 seconds ago. So now I want to click on this block. So if I click on this block, what was going to happen? Have I done that? Okay, I've clicked on this block. So, and let's see. Sorry, my network is not slow, but my PC is kind of slow. All right. So now look at this. See that inside this block we have 137 transactions. Can you see this? 137 transactions and 48 contract internal transactions. Can you see this guy? If you can see, just say hi.
Hi, hi.
All
Hi.
right. All right. So now if I click on this 137 transactions, what was happening, please? Uh, now, these are all the transactions in that block, right? Now, if I click on this, now how does the blockchain know that all these transactions are in that block? If I click on one of these transactions now, if I click on one of these transactions, let it load, you see something. Now you see that this is the transaction itself, and it's telling you that this transaction is in block 166998877. Now it is because of Merkle tree that this Etherscan Explorer is able to know the block that this transaction belongs to. Because of that stuff I told you guys, that block header and the transaction hash, the root hash of the block and all of that of the Merkle tree. Where is this guy? So it's because of this this last hash here. With this last hash, you can get all the transactions that are of this tree. And that is what we have here. So this is the blockchain structure. A block is made up of the block header, the list of transactions which are computed in form of Merkle tree. You have the nonce. So this nonce is used for proof of work. And you have the timestamp, that's the time that transaction was added, and the transaction root, which is the root of that block and all of that. So let's move to this guy. Okay, smart contract. Whatever we are doing in smart contract is just theoretical. Smart contract is a term used to describe computer code that automatically executes all or part of an agreement and is stored on the blockchain-based platform. Smart
Sorry,
contract
please. Your
works on
screen is
an
tiny.
oh sorry. Oh sorry. All right, let me just do this guy. All right. So smart contract is a term used to describe a computer code that automatically executes all or part of an agreement and is stored on a blockchain-based platform. Smart contract works on an if-then principle. That means if this thing is right, then do this. That is the if-then principle. Now, these are the properties of a smart contract: trustless, trackable, irreversible. Trust sense that Uniswap and PancakeSwap able. Now you see the way we're able to sharply finish up this guy, so we don't miss out anything. Okay, so this stuff you're seeing here, this is a video that explains how the blockchain works. So you see, this is Ethereum spec. Can you guys still hear me? So let me be sure I'm not out of the
Yes.
matrix.
Yeah, we can hear you.
All right. All right. So this is a video. I was watching this video some time ago. So this video is what explains the connection of how the Ethereum system works. this is my note when I was trying to understand it. So this video is not very clear. I had to add this note, the screenshot of this note here, so it explains everything. So Ethereum people on the Ethereum DAO or the Ethereum community, they will research on something. Once they research on something and that research is being agreed on, they call it EIP. You hear something like Ethereum improvement proposal. So they'll create an EIP proposal, and if that proposal is accepted, it's implemented in the specifications. Now, these specifications is like your algorithm. All of those that are front end or back end developers. This is like your algorithm, and your algorithm can be written with any language, provided all of them are working with the same algorithm principle. So that is what you refer to as Ethereum specifications. Now, these are the clients. The client, Ethereum clients implement the spec. So they implement that algorithm. And this spec is what contains the rules, the proof of work rules that these clients will write in their code. And these are different languages used or different clients. Like this get now, this get is written with Golang. And this is the most popular Ethereum client. Now, this client now is what these nodes, these are nodes, one, two, all these nodes, is this client that this node will install in their computer. It now gives them access to the blockchain, which is this guy. And anything they do in their computer gets updated in this world state. This is called the world state. The world state is the last state of the blockchain that everybody can see. So anything these nodes do is updated on this world state. And that is what this diagram is all about. Let's move to the next guy. This is the second slide. We're going to the third. So this is the last slide, multi-chain. So multi-chains, basically, we have Ethereum, Bitcoin, Binance, and different blockchains. What multi-chains do is, based on the fact that the way Ethereum smart contract work is different from how Bitcoin blockchain work, and is different from how Binance work and all of that. So multi-chain platforms are like an intermediary that helps connect every other blockchain to interact with each other. That's why I say a multi-chain is a network of bridges or parachains that link current blockchains to improve services and circumvent the constraints of earlier technology, Bitcoin and Ethereum. So it gives room for interoperability for different blockchains to work hand in hand with each other. And there are other things like bridges. You hear someone bridge a token from Ethereum to Phantom, from this to this, and all of that. So multi-chain gives that room for different blockchain technology and using different principles to work together and send transactions across each other and all of that. And I think that is the end of our stuff. Thank you for listening. Ask questions and research. But I don't know if we'll still welcome questions, so because we already asked a lot of questions. But if there's room for questions, then I don't know, Mr. Idris.
All right. Thank you so much, Mr. Speaker. I really enjoyed the session. I'm very sure everybody also did enjoy the session. Thank you so much. All this clap, all this emoji for only you. So does
Let me
anybody have a
clap.
question?
Let me clap for them too. I want to clap too for those that were able to stay to the
Okay,
end.
just two questions, please, because I have just 2 minutes to go. All right,
So
Uve.
can I go? Okay, yeah.
Yes,
So
1 minute, please.
yeah. My question is just like based on everything that we covered today, like broadly, and it's like my observation is like we went like surface level, like even in comparison to the notes, and definitely you had your reasons why. But like this is our first like session, so like you said, we don't know who the next person taking us, like who the person is going to be, or how like he's going to follow up or she's going to follow up in the teaching. But like will we be expecting like the same thing in the next class? And when I say the same thing, I mean like the same approach, like surface level.
Okay. Um. So not everything we do today is surface level. trust me, not everything we did is first of all understanding the concept of Merkle tree and all those crypto cash functions. They are not surface level actually, but you know, not everybody on this call might have read about the blockchain before. I know some persons here have already started coding, writing smart contract or coding Solidity. Some persons might have studied about the blockchain before, but there are so many other persons here that are completely green, like they are very, very green. So we can't use the approach of someone who understands the blockchain or smart contract to teach people that are completely green for the first time. So this surface level is just like starting from scratch for everybody to sing, to follow along. Don't worry. I don't know what they are. This is the curriculum I saw. I don't know what the next class curriculum will be. But once you start doing contract, if you have not written smart contract before, you will be the one that will say this thing is becoming complex. By the time you start hearing things like 3D mapping and all those things, storage slot and all of that, you will shout that it's becoming complex. And if you don't understand these basics, you will never understand those other classes. Trust me. If you don't understand this basic, this surface level, you cannot perform magic. There is no how you will understand those complex ones. And also, I don't know if I'm the one that will teach you smart contract. I don't know. But I'll give you a hint. When you start learning smart contract, please and please pay attention to the data structures. You see those things like mapping, arrays, structs, and all of that. If you don't understand them when they are teaching, if you don't understand those stuff, it will be hard for you to think of smart contract logic on your own. Those are the basics for writing good and complex smart contracts. So it won't continue to be surface level, but for the purpose of the people that are green, it has to be surface level for today. Then subsequently, the difficulty will progress accordingly.
Hey, boss, don't scare our people. So, the difficulty would increase, but that's if you have like a very good fundamentals, right? So, the reason of the reason why we started like this from scratch for you to understand what is behind the scenes, because we realize that at the end of the day, if you skip this and just jump right into smart contract development, or plug in your front end to a smart contract and all of that, you end up not getting it right. So we don't also, at the same time, we don't expect you to just understand this whole thing, right? Try and digest it bit by bit. Take time to just go through it on your own too. Time, we can't spend 6 hours here. We can't spend like, we don't have like luxury of time like that to spend to take you through everything every time. But one thing we can do, I know for sure, is that you can ask questions even outside this call. The speakers, the mentors that would be facilitating all these sessions here, they would they are on our Discord server. So once you drop your message, and probably maybe they have like a very good answer, a direct answer they can give you, they can share. If anyone else also wants to contribute, you can definitely contribute. So I think asking question would help you go far. So considering the fact that maybe you are a newbie, or you just started learning Web3 and all of those things, it doesn't really matter. What matters is, are you learning on your own after this call, and also are you asking questions? Like I mentioned on the onboarding call, like no question is dumb, no question is stupid. The only thing is that you are asking because you don't know. So feel free to make use of that chat to ask questions whenever you need clarity, or maybe there's something that was discussed here, then when you research, you want to even like contribute to the discussion, you can always drop it on that ask for help channel. Then you definitely see somebody else to contribute, and from there you can get clarity. So sometimes when you are explaining what I've figured, right, in this Web3 space generally, when you're having issues doing something, especially coding related activities, and you're trying to explain to somebody, that is when you finally realize what the solution is. The good thing is that the person might not even help you, but because you are trying to explain yourself either by chat or either by voicemail, voice chat or whatever, you figure it out at home. Maybe you can try this approach and this thing would work. So it just literally just ends um, to the fact that we need to ask questions, we need to build in public, we need to share ideas together, and that's how simple it is. And before you know it, you start getting things right on your own. Somebody asks, "Are we still meeting by 5 p.m. tomorrow?" No, we don't want to bombard you everyone with a lot of information, and at the end of the day, you won't learn anything. So it's ideal for us to just say, okay, we'll be having calls every day for the next um, 2 weeks, and we can just end it there. But that's not a good deal. We need to give you people also time to digest whatsoever has been discussed on this call, and also on your own try to understand the whole thing generally. So every other thing will be communicated, including the curriculum. Somebody asked about the curriculum. Yes. So the curriculum will be communicated, will be shared rather with you via email or maybe, okay, I think email or on Discord. And every other information, including the video, the recording for this, and the slide, will be shared with you on via your email and Discord server. Yeah. Pass the mic to Eniola. Thank you very much, Kaz.
All right, thank
Yeah,
you.
thank you so
Thank you.
much, Kaz. I really appreciate your patience and your time. So thank you guys. Thank you everybody for your patience as well. And I really hope